All right, everyone. Today's topic is numbers of solution. Our questions to think about: how can we determine how many solutions a linear equation with one variable has? And what does it mean when an equation has different numbers of solutions? Let's get to our notes section. We've been mainly dealing with equations where we have one solution, we solve it, and we get what x equals. And we can check that that works. But equations in one variable can actually have one solution, infinite solutions, or no solutions. We're going to use these tables here to kind of make sense of what these different options means and how to recognize when you have an equation with different numbers of solutions. First, to focus on our reasoning, what the type of solution means. What does it mean to have one solution? Well, only one value will make the equation true. Only one number for that variable. For infinite solutions, any value will make the equation true. That means you can use any number and it will work out. For no solutions, no value will make the equation true. That will work for no number whatsoever. When these different equations are true, sometimes a conditional equation is true for some values of x. This is only true one time. Oh, that should say 1, not true. Only true one time. For always, an identity is always true. An equation is always true for any value of x. It's always true. It's true every time. A contradiction is never true for any value of x. This is not ever true. A contradiction doesn't make sense. It doesn't work. Let's look at some examples. Here we've got 4x plus 6 equals 18. If we subtract 6 from both sides, that'll give us 4x equals 12. Divide by 4, that gives us x equals 3. 3 is the only number that makes the equation true. Whenever you can solve, do your balanced moves and solve, that's one solution. Here we've got 5x plus 15 equals 5x plus 15. These are exactly the same on the left and the right. If we subtract 5x from both sides, then that's going to leave us with just the 15 equals 15, which is a true statement. Any number for x will make the equation true, since it's exactly the same on the left and the right. For no solution, 4x plus 8 equals 4x plus 3. If we take away the 4x's, we have 8 equals 3. This doesn't make sense. This is a false statement. No number for x will make this equation true. Some things to look at when you're looking at both sides of the equation is for one solution, an end result still has a variable and a solution. Like that example we saw up here, x equals 3. Variables cancel each other out, and both sides of the equation look equal. Just like that one we had up there, 15 equals 15, or when it's exactly the same on the left and the right. That's infinitely many. For no solution, variables cancel each other out, and both sides of the equation do not look equal. Just like we had this 8 equals 3. Variables seem the same, but have numbers that do not match one another. So how do we determine the type of solution? Well, first we want to make sure we're dealing with the simplified equation. That makes it a lot easier, meaning you've combined all your like terms, you've distributed it, and you just have a simple variable term and a term without a variable, like this 3x and this minus 5. So what you want to do is look at these variables. In this first example, the variable terms are different. When the variable terms are different, the 3x and the 7x, those are different. That means there's automatically going to be one solution. Looking at the variable terms over here, 4x and 4x, we can see that variable terms are the same. We also can see that both sides, the 2 and the 2, those are also the same. So both sides are equal. 2 plus 4x is the same as 4x plus 2. That's always going to be true. Infinite solutions. Lastly, the variable term 8x and 8x are the same. So the variable terms are the same for no solution, but The constant terms, the terms without a variable, 9 and -5, those are not the same, so both sides are not equal. Let's take a look at how to determine how many solutions an equation has. Here's your steps. Simplify both sides of the equation. That usually means distribute or combine like terms if you can. Next, check if the variable terms are different or the same. If the variable terms are the same, check if both sides are equal. We're going to do a couple examples. As we pause, I want you to reference back, turn your page over, and look at this table to see if it should be one solution infinite or no solutions. Here we go. Example 1. We have 2 times 4x plus 5 equals 5 times 2x plus 4. First thing we want to do is simplify both sides of the equations by distributing. That means we're going to multiply this 2 times 4 and the 2 times 5. Also do the 5 times 2x and the 5 times 4. Do that now and write out what you get. If you did that correctly, you should have got 8x plus 10 equals 10x plus 20. Looking at these variable terms, we have 8x and 10x. We can see that the variable terms are different. One has an 8, one has a 10 with the variable x. Looking back at our table, which one says the variable terms are different? That should give you a hint on what type of solution this has. Since the variable terms are different, we can see that this can be solved. This is one solution. Let's move on to example number 2. We've got 10x plus 8 minus 11 equals 4x plus 6x minus 3. Let's start just like we did before. Simplify both sides of the equation. In this case, it means combine like terms. Try to combine your like terms on each side and see what you get. Do that now. If you did that correctly, you would have combined the 10x. 10x does not have anything to combine with, so that stays. But 8 minus 11 is minus 3, negative 3, equals the 4 and the 6 both have an x, so those can combine. 4 plus 6 is 10x minus 3. Take a look at those variable terms. That's 10x and 10x. We can see that the variable terms are the same, and we also have minus 3 and minus 3, which means that both sides are equal. Turn your page over, see which type of numbers of solution has the same variable term with both sides equal. That should give you your answer. This is a true statement. 10x minus 3 is always equal to 10x minus 3, which means we have infinitely many solutions. Moving on to our last example. We've got a lot going on here. Negative 4x plus 3 times 5x plus 6 equals 7 times 2x plus 1 minus 3x. Even when we have a crazy equation like this, we still start by simplifying both sides of the equation. It's usually easiest to distribute first. If we distribute the 3 times 5x is 15x. 3 times 6 is 18, which we get down here. 7 times 2x is 14x. 7 times 1 is 7. After we've distributed, let's try to combine the like terms. We can see that these negative 4x and 15x will give us an 11x. The 14x minus 3x will give us an 11x here. Then we're left with the 18 and the 7. Comparing these variable terms, 11x and 11x, we can say that the variable terms are the same. And we've got plus 18 plus 7. The sides are not equal. So, since we have 11x plus 18 equals 11x, same variable terms, not equal sides, look back over and see if you can find out how many solutions this equation has. This is a false statement. 11x plus 18 can never equal 11x plus 7. Therefore, this is going to be a no solution. These tables are very helpful. Always look back to these as you go through your practice problems. It's a great quick reference until you get really familiar with this where you have them without even needing notes. Take some time to write out your summary. Make sure you're answering those essential questions. Don't just summarize what we did. Explain the concepts in your own words. I hope this video was helpful.